Okay, so you should have your sheet out, your Microsoft Excel spreadsheet. Make sure you look at it closely now. Because if we don't have these in the correct format when we go to upload, we're going to have a tremendous time with errors. So on the symbol, notice I said it cannot have any spaces. No special characters, only an underscore. So start underscore PB is what I chose. The description, I chose just start PD. For the next one is stop underscore PB, auto underscore manual underscore SS, which is selector switch. So check them all and make sure that they're correct. Because any errors, and when we upload this data file, we're going to have problems. Okay, the descriptions are very generous. The way the descriptions work is transfer cylinder and then retracted. Notice that that's in a different column. So that means it's going to be on a separate line. So if you wanted to put it on a separate line, you could. Transfer cylinder and then extended would be on a separate line in the actual description. Suction cylinder extended would be all one line. Because if anything is too long here in the description as well, it's going to chop it off. So that's really not a big concern for us because we can always clean that up later. Okay, so hopefully you've got all your inputs in. Does anybody not have their inputs done? Yours needs to match what your paper says. Remember, we renamed the inputs to match what made sense to you. I'm not telling you you have to.
So how do we?
I'm just telling you why mine looks like that.
How do we move? We need to add a drawing up there. Like I always have 11 sequence that I need to add.
Okay, you have 11.
Yeah.
Okay, so you go right to where it says 11.
Yeah.
Click, left click, and then right click, and then hit insert.
Oh,
Okay, and that'll put in another column. Okay, we can delete that to get rid of it. Okay, now remember that your symbols and your descriptions need to match what your paper says. You should have created the schematic for these in ANSI format, right? That was your homework. To recreate an ANSI schematic, renaming the actuators and symbols to something that you understand. Yours may not match mine. Okay, I want to do something else right now. We got to make a little bit of prep work before we can dump this file. So on all of your guys' files, I need you to look at the bottom. Okay, you can continue editing here when we get done with this, but listen to me now. Over here, you have a tab at the bottom. What's that tab say? It should say Sheet 1, right? Down at the bottom. Okay, I want you to right-click on that and hit Rename. Okay, and when it turns black, give it a name. Call it Base Station. Okay, and then just hit Enter. Okay, right next to Base Station, you have Sheet 1 and you have Sheet 2, right? Okay, so you have Base Station now, you should have Sheet 1 here, and you should have Sheet 2 here. On Sheet 2, I want you to right-click on it, and then hit Delete.
Base Station and Sheet 2.
Okay, maybe you only have a Sheet 2. That's fine. You have Sheet 2, right? You have a Sheet 3?
Yeah.
Okay, so delete Sheets 2 and 3. Click on it, hit Delete. And then on the other one, do the same thing and delete. so that you only have one sheet in the file. Okay, everybody got it? Okay, everybody only has one sheet in the file, right? Okay, we're going to do a little bit more prep work here. So everybody just quit adding additional inputs and outputs right now. Follow me. You can add them here in a few minutes. I want you to come to the top. Yes.
This is not letting me, get out of it.
Hit the enter key. Did you get it? Okay, everybody eyes on the screen. We've got to prepare the file for transfer. We're going to click on File. Okay, you have a ribbon up there, a little Microsoft ribbon thing, a little office thing, right? Top left-hand corner. Okay, click on that, and then click on Save As. Click it. And you're going to see a window come up. Should already be named Base Station, right? Now, you're going to choose the down arrow as Save As File Type. You're going to go through there until you find one that says CSV.
Did you resave it?
Okay, you may not have saved it yet, so that's okay. That's fine. Click on CSV, comma delimited. Okay. File name, put a name in there and call it Base Station. And then underneath where it says Save As File Type, make sure that you choose the comma delimited. Got it? Okay, who doesn't have it yet? Okay, where are you at? Got it? Does anybody not have the CSV file type? Good. And in the file name it says Base Station, right? Okay, let's put towards the end of that, we're going to put a hyphen and we're going to call it a tag file. So Base Station tag file. Because that's what this is really going to be. It's a tag file. And then when you click on Save, you need to save it somewhere where you're going to remember where you saved it. Okay, flash drive if you've got one. If you don't have one, then you're going to need to save it on the desktop for now and then email it to yourself. And we can probably even move it into the thaw area on these computers. So hit Save. Okay, you're going to get an error or a warning. It tells you that this is a tag file and it's not compatible with other things. Okay, that's okay. We understand that. So click on Yes. And then you should get a position or area that it wants you to save it to. Now in the top it should say Base Station tag file, right?
Mine says the file name location is format base station tag file, not orange.
hit OK. We understand. Just hit yes.
That's a error when it's trying to save it. It won't let you save it.
What we're going to do is we're going to go up here and we're going to add just a little bit more information. So you should have an insert tab at the very top, right? Click on insert. I want you to go to header and footer. Okay, and in the header, I want it to say INDT 206 PLC 2. Hit the enter key and put your name on it. PLC 2, and then just click if you want to. Okay, and then just click anywhere on your screen and the header should go away. Okay, anybody having problems? So you've got a header on your screen. Just click anywhere after you've typed on your screen in a blank cell, and it should go away. Does everybody have a header? Raise your hand if you don't have a header. Good. I'm assuming everybody has it. We're moving on. We're going to go up here to page layout. Okay, click on page layout. And we're going to come down to orientation. We're going to click on landscape. Okay. Now after you've done that, I want you to click on the view tab at the top. Click on view. And you're going to come over here to where it says page break preview. Click on that. And your screen should look like mine when you do that. Okay, anybody not there? Alright, what we're doing is we're going to create a sheet for us to have in front of us. Click on the preview acknowledgement here and hit OK. Now you're going to come down to this line here that's dashed. We're going to click and hold when it turns into a double arrow, and we're going to move it up to the last input address, which is I:215. Okay. You have a dotted line, right? We're going to click on it. We're going to drag it up, left click and hold to the last address, which is I:215. So page 1 should be your inputs, right? Anybody not have that? Okay, now where it says page 2, you've got a line here on the bottom, right? I want you to left click and move it downward. Just a couple bits, okay? Doesn't have to go far. And you get another dotted line, right? You're going to take that dotted line and move it up to the bottom of your outputs. So now you got page 1, page 2, page 3, right? Okay, remember we took the bottom line and we moved it down. Okay, now we're going to go back to where over here on the top where it says normal view. We're going to click on that. All right. Then we're going to go right here to state B. Where the B is, I want you to click on that. So the whole column turns blue. Right click and hit delete. Okay. Now we're going to go to column and cell A1. Just click there. For now, once everybody's there, then move away, then move back to it, click and hold with your mouse. Left click and hold. Move to the right. Come down. Keep coming until you have everything selected. Okay, you can probably even go a couple extra lines. So you've basically drawn all your lines. Once you have that, go to the Home tab. Is everybody at the Home tab? Okay, right here above where it says address or FX or here or column B, come straight up and you're going to see something that looks like a window pane. It's called Borders. Click the down arrow and hit all borders. Okay, so now everything should be in nice column form. Okay, so everything is selected. You can just click anywhere and that should take the selection pane off. I want you to go to File, you go to Print, and you should have a Print Preview come up. Mine looks a little bit different than yours because I'm using 2010 software, you're using 2007. Okay, and then once you're ready, click on Print and choose the FW MAD printer, I think it is. It's the network printer. And then you'll go over and grab your sheets. Okay, so once you're ready to print, just hit Print here, and then I'm going to go back to the Home tab on the top. And you should be able to get back to your file. And now we need to put back in the column that we deleted. Do you remember how we do that? Control Z or undo, right? You got either one. Up here in the top are your undo and redo buttons, or you can just press Control Z. Alright, that's the last thing we're going to do now. We're going to go ahead and hit File and Save Again. Going to give you that tag file name warning again, but that's okay. We know about it. When you're done, hit Yes. Okay, after you've saved the file, you may then close it. And here we already saved it, so just hit Don't Save. Okay, so we're going to open RSLogix. We're going to come up here to the top. We're going to click on File, New, right? We're going to go through and we're going to choose our processor by scrolling down. Except for which processor are we choosing now? The one in front of you or the one that's sitting over in the corner? The one that's sitting over in the corner. You're not programming the stations in front of you, right? So you should have a sheet for over there. And it says the first thing that's in slot 0 is what? No, slot 0 always has CPU. What was the CPU? Correct, and then hit OK. Right? After we choose our processor, then we have to configure the I/O, right? So double click on I/O config, and then from here we got to tell it what's in slot 1, 2, and 3, right? What's in slot 1? Okay, for the base station, it's a 1747 SDN, right?
What processor is it? There's several 532.
Just choose a generic one, that's fine. If we don't get it correct, it will change it for us. Roberto, you'll need to put yours in there, okay? It's a RSLogix, right? Isn't it a 1500? Okay, slot 1 is supposed to have a 1747 SDN in it. Double. That's right. It's what SDN means. Okay? If you read the description, it says DeviceNet Scanner Module. Right? Okay? What's in slot 2? Very good. 1746 ID 16. Double click on it and it should go into slot 2. And then last but not least, what's in slot 3? Very good. OW16. 1746 OW16. Double click on it and just check them, but at this point do not hit read IO config, because if you do, what are you going to get? You're going to get the cards that are sitting in front of you, right? We're not programming that station. Okay, so if you've got all of your chassis loaded, come over here and click on the red X. You're done. Okay? Okay, now once you got IO config, we're ready to we're going to import our data files. We're going to go to Tools, Tool menu, you're going to scroll down to Database. You get a menu to the right, and we're going to click on ASCII to import. Okay, you get another menu that comes up. What did we just create in Excel? A CSV file, right? Click on that. It says on collisions, overwrite existing records. That's what we want. And hit OK. Now it brings up your tag file. You've got to find it. Where did you put it? Okay, I'm going to find mine. I know where I put mine. I put it in the PLC course for 206. And it should say base station tag file, right? Once you've got that, click open. And you're going to see some errors probably. Some of these errors or things may have already been in the database, and that's okay. For some of you, you may have had descriptions that might have been too long and it chopped them off, but we can always fix those later. So if you've got them imported, go ahead and hit OK. All right, now we're going to check our import to see how well it went. We're going to come down to addresses and symbols. We're going to double click. And maximize the window by clicking on the square. And here you should see all of your bits of information that you just put in ahead of time. You should have all your bit files here. You should have all your inputs here. You should have all your outputs there. So now we don't have to label any of that stuff in our program. It's already done for us. Okay? And for those of you guys who are not done on your file, that's okay. Finish your file. and then we can re-import again once you have it completed. Okay, so if you're done with that, click on the double square up in the corner, the dark one. Okay, that should minimize the window. Then click on the red X. Okay. Did anybody have any problems importing your data file?
That's okay, I'm gonna find 1746.
Okay, we're now really ready to start programming, so we're looking at our sheet. Said we need an electrical schematics, pneumatic schematics. We went through and reviewed all those. Okay, you've examined the base supply, and you've already created your sequence of events. You identified the slot, and now we're going to identify the I/O. We've done that a little bit. So we're going to look at our station now. It says place the station in auto mode. Okay, we need manual mode, and we need reset mode. But we still need a little bit more preparation before we can do those. So let's go to RSLogix. We're going to come over here to the right where it says Program Files.
You're not seeing that little toolbar, left hand side.
You're not seeing what?
That whole looking, you go there.
Okay, go to the top and click on Window and hit Arrange and hit OK. Did that pull it up?
Yeah.
All right, Program Files. You're going to right click on it and you're going to hit New. Okay, and on this one we're going to call this Inputs. Hit OK. We're going to do it again. We're going to right click on Program Files. We're going to click on New. We're going to call this Outputs. Hit OK. Oh. Guess I'm putting it in the wrong spot. Okay, we're going to do it one more time. We're going to right click on Program Files. We're going to hit New. And we're going to call this Steps. Hit OK. And do it again. We're going to right click on Program Files. And click on New. And we're going to give this a name of Management, but we're going to abbreviate it. MGMNT. Management. Hit OK. MGMNT. Then we're going to right click on ladder 2. We're going to rename it. We're going to call it Work Bits. And enter. Work Bits. Right click on ladder 2. Click on rename and call it Work Bits. And then hit enter. Okay, does everybody have ladders 2, 3, 4, 5, and 6? And you have them labeled correctly? Okay, now we're going back to our lab sheet. This is where we're going to put work bits into. So we're going to start by putting this machine in auto and manual. So we must grab an instruction to get started. So we click this and make it red, right? Come over here, click on Add a New Rung. Then we know it takes an instruction here of some type to turn on a bit of some type to create either auto mode or manual mode. Okay, here is why we did all of our hard work. Click on the first XIC instruction, turn it black, and then just start typing. AUC something or other, and your symbol should come up. Do you see it? Double click on it and hit enter. Auto manual selector switch. Okay, now we didn't create a bit for our auto mode, so we're going to have to do that on our own. We're going to come over here and we're going to click on binary, B3. Okay, we need our B3 files to program with. We only have one word of information, right? So we're going to click on properties, and where it says elements, I want you to change it to 10. Okay, we're going to put 10 elements in it right here. And then hit apply. Hit OK. All I did was come over here to the left and I double click on binary. That brings up my data file, right? Then I click on properties and I chose 10 elements and I hit OK. Now, in your sheet that you created, your tag file, what address did you start your steps at? Okay, B300. So you don't want to use those, do you? Okay. I chose a different one. So you're going to want to, let's go to, you're fine with B300, and you're probably going to need B3:1, and then you can probably start with B3:, let's just go to B3:3/0. Okay, that's going to be our next available bit. It's not going to do anything. We're just going to click on B3:3/0. Drag it over, drop it on the green X. Okay? Okay, so after you have the bit in, you can put the symbol in here. While the window is still up, you can call this auto _ mode. And then for the description, you can do the same thing. AUTO, auto mode, and then SS maybe for selector switch, and hit OK. So now that should put that information in there, right? Okay, if we'd have thought ahead enough, we could have included these in our data file. But we were running out of time. We got to start getting programming. So does everybody have an auto mode selector switch and an auto mode bit for OTE? Okay, I'm going to fix my screen here so it shows the symbol so it looks like yours. You're probably freaking out because it's not showing the symbol. So I want to let's see, miscellaneous, dominant display. Click on show symbols. Hit OK. So now hopefully it looks like yours, right? We have auto mode already programmed. That was it. That's all we had to do. Piece of cake, right? So how can we get manual mode? What is manual mode? It's the opposite of auto mode, right? So we put in a new rung. Okay? We put in what type of instruction now? It's IO. We want the opposite of that, right? Okay, I'm going to click and grab the address, I:2, just click right there, bring it down. And now I have the exact opposite of it, don't I? So I'm in one mode, I'm auto. When I'm in the other mode, I'm going to be manual. Okay, so you can bring it in, you can address this many different ways. You know that B30 is auto mode. So maybe we'll just start typing now. B3:3/ and you'll get something pop up as soon as you get the slash. It says the next unused bit. And you can click on that and be fine. Then hit enter. Now you're going to get your description type, right? So this is going to be what mode? Manual mode. Symbol is the same. Manual_mode. Then hit OK to acknowledge it.
So we want to get rid of the
Looking at our sheet now, reset mode is next. We're going to go back to our program, click on rung 2, turn it red. Now there's another way that we can insert a line. We can right click on it and say insert rung. Okay? So we don't have to go to the top. However you choose to do it is up to you. We're going to bring something down. It says when reset mode button has been pressed, I want a bit instruction to come on, an OTE. So what must this address be? Why don't you just start typing RES and you should have it come up in your suggestions, right? Reset. And then hit enter. Okay, we don't have to remember addresses no more. That's why we did this. We don't want to remember what I:23 is. We want reset. That's what we want, right? We're able to do that because we have used the symbols. One symbol only, right? That's why we said you could only use it once. Okay, so now we come over here and we need another bit. So we're going to use B3:3/ and I'll get the next unused bit, which then is going to be reset. Okay, reset mode is my description, and then reset _mode is my symbol. When I have that, I just hit OK. There it is. Okay, let's look back at our program to see what it tells it wants it to do. It says we're going to place the station in reset mode using a momentary PB, and we want to maintain reset mode for 5 seconds, right? So is our program code going to do what we need it to do? We gotta do some more tweaking here, don't we? What do we got to do? Right, if we need to maintain something, we need a timer. So let's branch around reset mode. Okay, here's where it changes. It's not the same as Logix Pro. We can move our branches in RSLogix. We're going to grab a TON instruction. I'm going to bring it down here, drop it right in the corner where that green X comes up. Let go. What timer do you want to use? You're the programmer. Does it matter? You can use T40? How about T420? 21? 50? 255? Sure, we choose. Doesn't matter. What? That's right. Okay, so let's click on T4:, and it's going to tell you the next unused element is 0, right? On the timer, just start typing T4:. Double click on it and then hit enter. Okay, and we're going to say that this is our reset mode timer. And we don't need a symbol per se. I mean, you can put them in if you want to, but they really don't do us a lot of help. and just hit OK. What is the time value that we want the preset to be?
1 second.
Okay, we're going to count in increments of 1, right? So that's fine. Do a 1.0 timer. What should the preset be then? 5. Absolutely. Accumulated is going to be 0 because it's not incrementing, is it? Okay, so you get your reset mode timer in, and now we got to make some changes to this code so that the reset button is going to do what when we let go of it? I heard it. It's going to seal in. That's what you said, right?
Yeah, seal in.
That's what I thought you said. How do we achieve a seal in on the reset button? We got to branch it, right? So go back to user. Okay, we're just going to put a branch around it. Okay, in the corner we want to put an instruction that's going to help us get a branch. And what do we want this address to be? Sure, same as the reset. Drag it over, drop it. Okay, so we're almost done. What's going to shut this thing off after 5 seconds? We need a done bit. But what type of done bit? Do we want normally open or normally closed? Or does it matter? Can we use a done bit? Yes. Can we use a timer timing bit? Yes. You could use either one. How long is the timer timing bit true for? As long as the timer's incrementing, right? Which would equal how long? 5 seconds. When does the done bit go true? So which one can we use? Either or. Your choice. Typically we use the done bit. We program it as an XIO. Okay, and we address it as done. Now here's how I recommend you address your timer bits. Click on your timer file on the left. T4 should pull it up, right? Come over and literally click on the 0 where it says done and hold. Should turn blue. Drag it over, and as soon as that red box that you see turns green, let go. Why is it recommended that we do it in this mode? Why is that the better way of doing it? That's just called rung wrapping, but why is it preferred to go and drag the address in versus typing it in? Because when you type it in, you're probably going to make mistakes. Okay, this is foolproof. It's addressed correctly every time when I drag it in. Okay?
The base is good, or the time base is different from what we program.
Okay?
What this file says. The file says point zero.
That's because we haven't downloaded the program yet, so it hasn't updated anything. If you click on verify at the top, it'll probably change it. See how it just changed it? When I verified it, that time base changed, didn't it? Okay, you've got to just click somewhere on the white page and then click on verify. And did your timer change the base? Okay? Good. All right, are we going to be able to get by with one timer in this program?
No.
How many do you think we should add? Just click on properties on the timer file. Under the elements, let's go with about 20, okay? Hit apply, then hit OK. So now we should have 20 timers available to choose from. You like that, don't you, Jarrell? Okay. So, very good. We've got timers to choose from. Now, if your screen looks like mine did here, where it rung wrapped, if you want to hit the minus button up here, which is zoom out, until it goes back to one rung, you can do that. Okay? So, on our program now, it said we needed auto mode, manual mode, and reset mode, right? Have we programmed those modes? We have. Do they do anything yet? They don't do anything. All it is a mode. We're going to use that mode later on when we start making the thing work. These are called work bits, right? Okay, we're not ready to create a home position. So we're going to do the next thing here, which is create a condition that will trigger a start event for one program. Okay, so we're going to come down here into our program. We're going to click on rung 3. We're going to right click. And we're going to click on insert rung. I'm going to come and grab an instruction that when it becomes true, the start button will become true. Okay, I'm going to go ahead and put an output on here as well. And then I'm going to click and change the menu up here from user to bit. Okay, and then I'm going to grab that guy that says OSR, which is one shot rising. Click it, I'm going to bring it down and let go. Okay, so what was this guy here supposed to be? Start. So just start typing. S-T-A-R, and what do you find? How do we know it's the start PB? What does it start with? I for input, right? That's the real world address. Double click on it and hit enter. Okay, now we've got a one-shot rising bit, and those must be addressed internally as a bit. So we need to use another bit. What's our next available bit? Well, if you don't know, just start typing B3:3/3, and it should come up. Hit enter. Okay, we don't really need to address or symbol this, but we're just going to call it OSR. Hit OK. And we only use that bit how many times in our program? Once. A one-shot rising bit can only be used once. Okay, so now we need a mode over here that says when we've pressed the start PB and it became true for one scan only, we want this to be what? What should this bit be? Start bit, right? So let's just start typing. What's the next available bit? B3:3, and it says 4 is the next unused bit. Double click on it and hit enter. For the description, start PB is fine. Okay, and then at the end put OS for one shot. Okay, and our symbol is going to be start PB_OS. Start push button one shot. And then hit OK. Okay, everybody get it? So now that we've programmed the real world input here, and we created a bit here, Which one of those two am I going to use in my program to know that when something has started? Am I going to use I:20 or am I going to use B3:34? I'm going to use B3:34. So I will never use the I:20 address probably again in my program. Because now I have better than I:20. I have start PB, which is only going to be true for one scan. That means I will get one scan only when I push the button, which is what we want. Okay, so we've programmed that. Okay, what is next in our program here? Well, we got to figure out how to do that home position. What is home position? Yeah, that's a good term. All of the actuators are where they need to be before we can start the system. Okay, sometimes actuators or cylinders, whether they be hydraulic or pneumatic, may drift. That's the case. Are they home? No. So we must make sure they are home before we start the system. So we do that with a check called home position. So how do we create home position? B3, it could be, but basically it's going to be a bunch of information looking at inputs that says home, right? So let's start working on that. That's going to be our next one that we're going to do. But to do home position, we need to do some more information. So this was our work bits, which let's go ahead and click on rung 0 here. I want you to right click on rung 0 and I want you to hit edit the title. Under page title, I want you to call it work bits. And hit OK. So now you'll see at the very top of your page it says work bits, right? Now we're going to come over to inputs. We're going to double click on ladder 3, which is inputs. Let's go ahead and right click on rung 0 in ladder 3 and let's edit the title and call this inputs. Hit OK. Alright, looking at your schematics, the real schematics, either the SMC ones or the ANSI ones that you converted, what's the first input? Okay. Do we need additional information or can we provide additional information on a start PB? Might we want to know a little bit more about the start PB than just whether it's on or off? Start PB we can probably get by with. What's the next one?
Stop.
Okay. Do we want additional information on a stop button? When we press it, what do we want it to do? Stop. So we probably don't need additional information there. What's the next button? Auto manual. Okay, when we flip it to auto, we want it to go to auto, right? Okay, so we probably don't need any additional info there. What's next? Reset. Okay. Do we want any additional information on reset? We could. I mean, what if somebody inadvertently pressed reset and reset the machine? What if it was an accident? Could we put additional information on the reset button to say that maybe after the reset button's been held, for maybe a second and a half, then the reset button would initiate? Couldn't we? Probably don't need to, but we could. Okay, what's the next thing on your paper? Okay, I hear a transfer cylinder retracted. Okay, you guys probably named it something else maybe. Do you want additional information on that? Absolutely. Because do you know if the input is actually on, if it's really retracted? No, you don't, do you? We can provide additional information that says that it most likely is retracted. So how can we do that? Okay, what does it take to get a transfer cylinder retracted? This is a physical movement, right?
No.
Takes an output, doesn't it?
Yeah.
Doesn't an output have to come on? Okay. So the output must physically come on. And what else would say that the transfer cylinder is retracted? Yeah, the reed switch has to be true. One more piece of information. Can the transfer cylinder be in two modes at the same time? Can it be extended and retracted? Could it theoretically happen that both proc switches come on? It can it? So if both proc switches are on, is it extended or is it retracted? Don't know, do you? Okay? So we need to provide some additional info here to prove if this thing is really retracted. So let's do it. Let's put an input in. Go to user, put a new rung in if you need to. There we go. I don't know why it did that. What did I do here? Alright, let's edit that. So edit the title. And we'll fix it here in a few minutes. Let's see what happens. Oh, it's because we got two end rungs. That's why. So we just need to delete that one. Okay, and then we're going to... We shouldn't have put the page title on there yet. So let's edit the title and get rid of it. Okay. Okay, and now we want to put it on this one. So we're going to right click, edit title, call it inputs. Alright, so we need a piece of information that says that the transfer cylinder is what? Retracted, right? So I'm just going to start typing, and there I see it immediately. Transfer cylinder is retracted. Double click on it and hit enter. Now you might have called yours something else, and that's fine. Just make sure that you start typing that piece of information. Okay, if the transfer cylinder is retracted, well, let's go ahead and let's think about what also must be true. Can it be extended if it's retracted? It can't, can it? So let's grab an XIO here, and we're going to say that this is transfer cylinder extended, right? And hit enter. If the transfer cylinder is retracted, should the output be on or off? Look at your schematics. How many coils are on the transfer cylinder? Look at your pneumatic schematics for the transfer cylinder. How many coils are there on that cylinder? One or two? Two. What does that mean to us? One in, one out. So if we want to make sure that this thing is retracted, should the output be on or off? Should be on. I know you said that. Which output is that? Look at your schematics. Which one on there says that the transfer cylinder is retracted? Okay, could be. Might be something, should be 2.4, but you may have called it something else. So let's do this. We're going to grab an XIC, and I'm just going to start typing, let's see, retract transfer cylinder. There it is. Because I put it in as a symbol, remember? All I had to do was start typing. O:32 is what mine says it is. What's yours? You're working on the other station, aren't you? Excuse me? Okay, so now we're going to put that timer in, T4 colon. It says the next unused element is 1. I'm just going to click on that and hit enter. We're going to call this transfer cylinder retracted verification timer. And we don't need a symbol for it. And I'm going to hit OK. So whatever you called this particular input should be retracted, and it should be a verification timer. We're going to use a 0.01 because we don't need a lot of time here. And we're going to go with 10 counts of a 0.01, so a tenth of a second. Accumulated, we're going to leave it 0. Okay, so you should have a timer here. Okay, and we may want to prove that this cylinder has been back for a certain amount of time before the input really becomes true. So we're just adding additional information here that's really going to prove that this cylinder is back. So we put the timer in here. Now we must branch it. Okay? So we're going to branch it, and we're going to put another instruction in the corner. And we're going to put an output in the corner. Okay, our input instruction is going to become T4 :1/done. Because that is what we want to see happen. Okay, so now the next thing is we got to think about our bits now. What was we using before? B3 : what? Right, but we was using a word of them, right? We kept going in sequence, didn't we? Those were for work bits, wasn't they? Right? I mean, all those were work bits. So let's use a different one this time. So we're gonna go over to our binary file. Okay, we're gonna click on usage, and now it should say that I've used all these in B3:3. Right? Those are all my work bits. I'm going to go ahead and jump down to B3:4 now, because these are all timers. You try to keep things consistent. Okay? We're going to use a whole new word and start programming. So we can grab B3:4/0, bring it over and drop it on the OTE instruction. And now, here's the kicker. This has to have a new symbol. So So we're going to say that this is going to be the transfer. And I'm doing this in the base here. Transfer underscore, and then probably just RET, retracted. Okay, and for the description, I do the same thing, transfer cylinder, retracted, and I have it. Okay? So now, if we look at this and read the code, it has more information in it than before. Before, all we knew was that the transfer cylinder retracted input was on. That's all we knew. We didn't know if it was actually laying on a tabletop somewhere making a switch, or fell off the side of the cylinder, could have made it that way. But now we know that it takes more to prove it. So we're going to say the transfer is retracted. It is not extended. The output to retract it is on. We're going to start a timer, and then after a little bit of time, that transfer cylinder should be retracted. So which one provides more information? This one or this one? Our programmed one does, doesn't it? Because if you think about the transfer cylinder, if it's out, how long does it take to get back? Could we time that and know that it took a certain amount of time for it to get back? We could, right? So here we've got a whole lot more information in this program logic than just using transfer cylinder retracted. Now, every time I want to know that the transfer cylinder is retracted in my program, which one do I use? Do I use I:24 or do I use B340? B340. I am done using I:24. I'll never use it again. Because B3:40 provides a whole lot more information. This is what programming is all about. We control things. We tell it how we want it to operate. This is not like a math class where 4 plus 2 equals 6. It's not. I mean, we determine the outcome. Yes?
So, like, we're still working on our list.
Correct.
Like, the program didn't go in and recognize it, so we have to go.
You know that the transfer cylinder is retracted. What else do we know is next? Look at your input sheet. What does it say? It should be extended, right? Okay. So let's do it. Let's put a new line in. Going to insert a rung. I'm going to grab an instruction. And this instruction, we're going to say that the transfer cylinder is extended now. And hit enter. So if it's extended, we don't want it to be what? When it's extended, can it be retracted? No. So we want to make sure it's not retracted. So now it's transfer cylinder retracted, right? And how do we get the transfer cylinder to actually extend? Needs an output, right? Oops. Pretty much. We need to know if the output is on, which is to extend the transfer, and I have it down as O:31. Okay, and then we do the same thing. We're going to start a timer. Our next available timer should be T42. Hit enter. And this becomes transfer cylinder extended verification timer. And you don't need a symbol, just hit OK. Again, we're going to use a 0.01 timer. Give it about 10 counts of a 0.01. So it should look something like that. And then we're going to branch it. Branch it and do the exact same thing that we did on the top, on the previous rung. It will be when I get done with it. I'm lazy. I'm terribly lazy. I cheat all over the place. Okay? Okay? So it should look something like that. Okay. Who can read that code to me and tell me what it says? Eric? Read the code and tell me what it says. Yep. Read the code on line 1. Right? Right? Okay. Alright, let's do that one next. Okay, we can do these in any order we want. It doesn't matter the order that we do them in. So I'm going to help you do this one, and then you're going to finish them. Okay, you're going to add a line. Maybe. Okay, or a couple lines. Okay, so the inspection cylinder extend is information, right? So we need an input telling us we get that information. What is the address of that? Or just start typing. Right? Inspection cylinder extended is what I have. Is I29. Okay, if the inspection cylinder is extended, it cannot be retracted, right? Do we have an input to tell us that it's retracted? So we can't use that, can we? But if the inspection cylinder is extended, what requires it to make it extend? The output, right? Okay, and what is the output? I'm not sure, but it's probably extend inspection cylinder, and mine says it's O:36, and I hit enter. So now I don't have any more information that I can include here, do I? That's all I have. So I'm going to go to timers, and I'm going to put my timer in now. T4, whatever the next unused element is. Hit enter. I'm going to call this the same thing, inspection cylinder extended verification timer. And hit OK. This one, I'm going to use a 0.01 timer. want to give this one a little bit more time because I really want to make sure that this is either extended or retracted. So I'm going to go to 20 counts, 0.2 of a second. And then how do I do the rest of it? What goes down below? Same thing we did here, right? Notice you should be seeing a trend, right? A pattern is developing. Okay, so all we're going to do is we're going to repeat exactly what we've been doing on all the previous runs. So you can type it if you want. You can go get the bit if you want. However feels comfortable to you. You did?
Yeah.
Okay.
I had, my section cylinder, labeled as 10.5 and input and output.
Okay. Give me a second. We'll come and look at it. We'll see if we can fix it. Okay, so B3:42 is my next available bit. I hit enter, and this now becomes transfer. Oh, no, I'm sorry, inspection. Extended, right? As the description. Symbol is going to be the same thing, transfer. Extend. Why do I keep saying transfer? Inspection. Extend. There it is. Okay, so let's do it. We're going to say that the exact opposite is going to make it retracted. So we got to put in a rung. Except for that's not the opposite, is it? So I put the wrong instruction in. So we want the opposite of that top one, don't we? Okay, so can we just grab these addresses and say I-29 and pull it down? O:36 and pull it down. And then we're going to do the same thing. We're going to put a timer in. Next available timer is what? 4. Okay, we're going to do the same thing. We're going to call this the inspection cylinder retracted verification timer. Hit OK. Change it to a 0.01 timer, and we'll give it about 20 counts accumulated at 0. Okay, so you guessed it, we do the exact same thing, branch it. Okay, so you can put the finishing touches on it here, T4:4 done, and then this is going to be what? B3:4 / whatever the next unused bit is. Hit enter, and now this becomes inspection cylinder retracted. And the symbol is inspection. I usually abbreviate these. Inspection retract would be fine. Okay. Alright, now if you scroll up or you scroll down through your program, you should notice that everything is looking almost identical, isn't it? All you have to do is repeat what we've been doing. Yes?
I used to be for colon.
Okay, we put 4 of them in here to get you started. You've got transfer retracted, you've got transfer extended, inspection extended, inspection retracted. So we've created all new programmed logic for every one of those bits. All we do now is we continue on with the remaining input devices that we're going to put additional controls on. So you have how many more cylinders? Probably 4, 5, 6 maybe in there. We need to know that every cylinder is either extended or retracted. And we may need to use some more ghost logic.
So the push button ones, we don't have to, because we did that in the work.
You can if you want to do it to a push button, but it's not really necessary because it doesn't really help us a whole lot. It doesn't give us a lot of extra information except for time. Same thing with a reset button. The only extra information we get would be time. Right? So they're really not necessary. It's the positional ones that really provide us information. So when you get to the reject cylinder, how many inputs do you have for that? Okay, how many inputs do you have for the reject cylinder? 1? Somebody should say none. Is that a problem? Can we tell if it's extended or retracted? How? What does it take to extend it? Output. So if we tell the output to come on, after a certain amount of time, it should become extended, right? If we turn the output off, after a certain amount of time, it should be retracted. So even though we don't have any physical inputs, we can still create some input logic by looking at the status of the output. Okay? It would be nice if we had inputs on there, but we don't. But we can use the output as an input device. I mean, if you've got a cylinder that's 20 foot long, right? How long does it take that cylinder to retract? Could be 1.5 seconds, right? Depending on how fast it goes. Tell it to retract, and then 1.5 seconds later, it should be retracted, right? Even though we don't have the positional information, we can look at the output and know whether it's extended or retracted. So you're going to continue writing all that logic for all of the inputs for next week. You should have each and every one of them ready. So, yes, I'll show you how to do it here in a minute. There's one more thing that I want to show you to do, because you need to do this for next week as well. Okay, we did input logic. We're going to go back to work bits. Okay, we need one more thing in our work bits now. So I'm going to put in a new rung. And if we look here, it said we need a home position, right? Okay, and we know what home position is now. It's all of our cylinders where they're supposed to be before we start the process. So we're going to come back to our program, and this one here, I'm going to start with the output, because I know this is supposed to be home position. I can start with inputs, I can start with outputs. And what bits were we using for work bits? What file? B3:3, right? So we'll just start typing here, B3:3. :3/, and I get the next unused bit, which should be 5, right? And I hit enter. And then I'm going to call this home position. And hit OK. So that's my goal, right? That is my goal, is to create a home position. Now, how do I get to that goal? Right, I put those bits in there. So I'm just going to put a couple in here for now because I know that we created some. So I'm just going to put 2 right here, and then I'm going to just go glance over at my input logic. And I know that I made a transfer retracted, and I also know that I made an inspection retracted, right? Do we want both of those cylinders in the retracted position in home position? We would, wouldn't we? So let's go back to input, or go back to work bits, and I'm just going to start typing transfer, and it's going to pop up. But which one do I choose now? I choose the B bit, right? Transfer retracted and hit enter. And the other one we programmed was what? Inspection, right? Or whatever you called it. All I do is start typing and I see it come up. I want the B bit. And I hit enter. So for you and for next week, you should have a whole lot more conditions that create home position, right? But you can't really add those until you continue defining your input logic, right? So really, by next week, there's no reason that we shouldn't be able to download your programs into the PLC and verify auto mode, manual mode, reset mode, and home position. Maybe some minor tweaks, and you will have all those modes ready to go. Then the next lab is where we're going to start adding and using all those work bits and pieces of information.
Now, if we save this file, we can bring it up at home.
I'm going to show you how to do that right now. Okay, let's do this. Everybody's eyes on me and attention on me. This is a RSLogix 500 program that we're writing. It's a full-blown version, right? We're going to go up here, we're going to get File, Save As. And we're going to call this Base Station _R1 for revision 1. And you're going to save this in your flash drive where it makes sense to you. Hopefully you have a folder now called PLC. Okay, everybody got it. Once you have it, hit save. Okay, now up in the top left, it should say Base Station R1. You see that? Okay, this is the program that we use in the classroom because we have a full-blown version. Now, we're going to come over here to the left where it says Controller Properties. Double click. Because now we're going to convert it to something that you can use at home using the free software. Okay, follow me, Randy. We'll just come over here to hit the escape key a couple times. Okay, controller properties. Now, with the free software, you can only program a RSLogix 1000 or 1100. So you're going to scroll through here on the drop-down arrow until you find RSLogix 1000, nothing more, nothing less, right here. RSLogix 1000. Okay, Randy, you got it? So after you get 1000, hit apply. And it says changing the processor type is going to result in a loss of data and or I/O configuration. Are you sure you want to continue? Yes, we do. We're going to hit OK. Okay? And then hit OK again. Now in the lower left hand corner you see where it says program files and it says errors, right? We expect those errors because we cannot have an I:2 or an O:3 in a RSLogix. It's not allowable. Those are reserved for modular PLCs, right? The RSLogix is a fixed I/O. So it's going to say that you have errors. And it's just going to say that that address is unconfigured. And it will be. Okay, that's not a problem. Same thing with file 3 is going to be all your outputs. Right? It doesn't know what O:3 is. It doesn't know what I:2 is. So if those are the types of errors you're getting, that's fine. Okay, so after you've changed the processor, then come up to the top and hit File, Save As, and on the very end of it, R1, you want to click, put a space, a dash, and call it micro. When you're done, hit Save. So now, up in the top left-hand corner, it says Base Station R1 Micro. Right? You're good to go. This program can be worked on at home with the free software, which is what I recommend you use. It's going to save you tremendous amounts of time. Okay. So that concludes today. We got a good start.